So the topic of discussion is the fault tolerance, because we know that in the distributed system there are possibility of getting the fault, and so the system should be designed in such a manner that it should be fault tolerant. And this tolerance of the fault can be done by two ways. The first is to uh, if there is any failure, we will be able to mask that failure so that uh, the system will be able to perform its specified function even after the failure. And the second one is that if the failure is going to occur, the system should exhibit uh, a well-defined failure behavior so that uh, uh, it will be able to facilitate some kind of action which will be more suitable for the delivery, for the recovery. So uh, normally the fault can be tolerated uh, by using the redundancy procedure, in which the system is going to employ a multiple number of processes, multiple number of hardware components, multiple number of copies of the data, uh, so that the whole system can work independently even in the failure mode. So to avoid this kind of fault which is occurring and making the system fault tolerant, we have two types of protocol. One is commit protocol and another is the voting protocol. And the commit protocol is going to implement the well-defined behavior of in case of the failure, and the voting protocol used to mask the failures whatever is being obtained in the system. So but before we are going to discuss about the how to implement these protocol to make the system fault tolerant. There are certain issues which is necessary to be discussed. The different issues which lies with the fault tolerance is, first is the process death, because we know that the system have to behave in a very specified manner in the event of failure. So uh, before we are going to design the system so that it will become fault tolerant, we must take care of these three kinds of failure, that is the process failure, machine failure, and the network failure. What is the process failure? Because it may be possible that certain resources has been allocated to the processes, and if the process is going to failure, it is going to fail, then it becomes necessary that whatever resources which are allocated to that process must be uh, re-evacuated. Otherwise, when the process is going to fail, the resources are also going to be lost. Since we know that most of the distributed systems are designed with the and are based on the client server model, in which the client will be uh, requesting the services from the server, and if the server process fails, then it becomes necessary that the client machine, it is required that the client machine should be informed, so that the client process which is waiting for the reply can be unblocked and should take suitable decision or should suitable action. Similarly, if the client process is going to fail after sending a request to the server, it becomes important that it becomes important as far as the part of the server is concerned, that the client process is no longer existing. So by this, by doing this, it is going to facilitate the server uh, in reclaiming the resources which is allocated to the client process. So both the possibilities are there. Either the server process is going to fail or the client process is going to fail. And in both the cases, anyhow, the information must be reached. If server is failed, the client should be able to know that the server has been failed, or the process of if the client process is going to fail, the server process will be able to know that it is going to fail. The second one is the machine failure. In this case of the machine failure, all the processes which are running at a particular machine are going to fail or going to die. So as far as the behavior of the client process or the server process is concerned, now possibility is that either the client machine is going to fail or the server machine is going to fail. But if the machine is going to fail, it is whether it is a client machine or it is a server machine, there is no much difference as far as the behavior of the behavior of the failure or the death of the processes which are running on those machines are concerned. But the difference lies that how we are going to detect that how the failure has occurred. So in this case, if the process is going to die or fail, it may be possible that the other processes may be active. So a message which will be stating that the process has died uh, can be sent to the certain other processes which is inquiring about the existence of the process which has been failed. Otherwise, if there is no message which is being sent or any kind of absence of any kind of such messages, it is going to indicate that either the process is going to die, the process has been failed, or the machine is being failed. The third one is the network failure. It occurs just because of the failure in the communication link. And if there is any communication link failure, it is going to uh, partition the network into different subnets and making it possible for a machine to communicate with the other machine. Uh, it is not will be possible to communicate uh, one machine with the another machine which is lying in the different subnet. So in this way, in this particular case, the process will not be able to tell the difference between the machine failure or it is a communication link failure until the communication network uh, it is able to recognize that a machine has been failed. So if the communication network cannot recognize the failure of the machine, thus it cannot return a suitable message in the form of an error code. So a fault tolerant design have to be assumed that the machine may be operating and the processes on that machine are active or not. Now we have to discuss the commit protocol, but before going to discuss the commit protocol, let us discuss what is the atomic actions and what is the meaning of committing. Now, atomic actions are the basic building blocks for the construction of the fault tolerant operations in the distributed system, because it is going to provide a mean, uh, a resource to a system designer. It is going to it is going to facilitate the system designer to specify the process interactions and process interaction that are to be prevented to maintain the integrity of the system. So as far as the atomic actions are concerned, the first action which is said to be atomic, if the process which is performing, it is not able to aware about the existence of the other active processes, as well as no other processes. Other processes are not able to aware about the activity of the process during the time when the process is performing certain action. The second one is uh, the action is said to be atomic if the process which is performing, it is not communicating, does not communicate with the other processes while the action is being performed. And the third one is the action is atomic if the process performing, it cannot detect the state changes except it is performed by itself, and it does not reveal its state changes until its action is going to complete. And the last one is that actions are atomic if they can be considered so far as the other processes are concerned. The actions are atomic if they can be considered as the process is indivisible as well as instantaneous. So that the effects on the system uh, should be visualized as the interleaved in comparison to the concurrent system. Now, we also know that a lot of transaction is going to happen, and whenever we have a lot of transaction which used to happen, uh, we can call that it is a transaction group. So the transaction group is a sequence of actions, and the group is treated as the as an atomic action to maintain the consistency of a database. So at a certain point during the execution, the transaction will be able to decide that whether it is going to commit or going to abort its action. So what is the commit action and what is the abort action? A commit action is an unconditional guarantee that the transaction will be completed. Or in other words, you can say the effects of the action on the database will be permanent. An abort action is a kind of an unconditional guarantee to back out of the transaction, and it is going to affect its action. It is, and none of the effect of its action will be able to persist whenever there is an abort action. Now, commit is a kind of a action whenever it has to complete its operation, but the abort action, which can occur during a transaction, uh, it may be due to the deadlocks, it may be due to the timeout, protection violation, it may be the consistency violation. Anything can be able to make the transaction to abort. So to facilitate this backing out of this abort action, the write ahead log protocol, which was discussed earlier, and the shadow pages are employed. Now, what is commit protocol? This commit protocol is going to enforce the global atomicity, which means that a transaction must be processed at every site, or it should not be processed at any site. Meaning thereby, whenever we talk about the commit protocol, it is going to enable the global atomicity in which the transaction has to be which has to be processed at every site. It is going to commit or it is going not to commit, just to maintain the integrity of the data system database. And the commit protocol is going to ensure that all the sites are either committing or it is going to abort the transaction unanimously, even in the presence of the multiple or the repetitive failure. So we have two kinds of algorithm in the commit protocol. The first one is the two-phase commit protocol, and another one is three-phase commit protocol. So what is the how it works? The two-phase commit protocol. It seems to be a very simple one, and this protocol assumes that one of the cooperating processes acts as a coordinator, and the other processes will be working as a subordinate, known as cohorts. And cohorts are assumed to be executing at the different sites. This protocol also assumes that we have a stable storage at every site, and write ahead log protocol is being active. So in the very beginning, when the transaction starts, the coordinator sends a start transaction message to every cohort. So what happens in phase number 1 at the coordinator site? What happens? What kind of activity is being done? So first of all, the coordinator sends a commit request message to every cohort, requesting the cohorts to commit. And once it sends this commit request message to all the cohorts, the coordinator waits for the replies, uh, which will be which the coordinator is expecting from the cohorts. So in this phase 1, what happens at the cohort sites? That once the message commit request message which has been sent by the coordinator has been received, the cohort is going to take the action. So if the transaction which is executing at the particular cohort, it is successful, it writes undo or the redo log on the stable storage and sends an agreed message to the coordinator. Otherwise, if it is not so, it is going to send the abort message to the coordinator. So that is the phase 1 of the two-phase commit protocol, in which the coordinator is taking the initiative by sending a request message to all the cohorts requesting to commit, and waits till it is going to receive the replies from the cohorts. And once this message has been received by the cohorts, what they will do, if whatever transaction they are executing, if it is successful, they log their record in the stable storage and sends the a message in the form of a agreed message to the coordinator. And if it is not so, the transaction which is being executed at the cohort is not uh, successful, it sends an abort message to the coordinator. So this is the phase number 1. Now the phase number 2. Now in phase number 2, what happens at the coordinator site? That if all the cohorts, there are possibility that there may be many cohorts. So all the cohorts, if they are replying agreed message to the coordinator, and coordinator is also going to agree to make the transaction successful, then the coordinator writes a commit record into the log, stores it into the stable storage, and then it sends a commit message to all the cohorts. Otherwise, the coordinator sends an abort message to all the cohorts. So once the cohort, all the cohorts has replied agreed, then only it is going to write the commit record into the log and send the commit message. But if any one of the cohort has not replied, or replied not in the form of a agreed message, but in the form of a abort message, it is the duty of the coordinator to abort the transaction and send the abort message. So it depends that in phase number 2, the coordinator is sending the commit message or the abort message, depending upon whatever reply it has received from the cohorts. Now, once it sends this message, commit message or the abort message, the coordinator waits for the acknowledgement from the each cohorts. Now, if an acknowledgement is not received from any one of the cohort, or time, whatever specified time with which it can expect any kind of acknowledgement, then the coordinator side, it is again going to resend the commit or the abort message to the cohort. So for a particular time period, it waits, and for the acknowledgement, if it is not received, it will again resend the abort or the commit message to the cohorts. And if all the acknowledgements are received, the coordinator writes a complete record to the log, just which indicates that the transaction has been complete. So what happens at the cohort side? Once it receives this commit message, suppose all have given the agreed message and it has written the commit record into the log. So it will send a commit message to all the cohorts. So once a commit message is being received, the cohort is going to release all the resources and the locks which are held by different cohorts, and for executing the transaction, and sends an acknowledgement. And on receiving an abort message, once instead of commit message, if the coordinator has sent the abort message, the cohort undoes the transaction using the undo log record and releases all the resources as well as the logs by performing the transaction, not performing the transaction, and sends an acknowledgement. So in both the cases, the cohorts has to send the acknowledgement either in the form of a commit message which it has received, or in the form of the abort message which it has received. So in both the cases, it has to send the acknowledgement message to the coordinator. So what happens if there is no failure and there is no loss of messages? Whatever coordinator has sent within a specified time, it has been received by the cohorts, or whatever cohorts has replied to the coordinator, if it is received by the coordinator, then there is no problem, because if there is no failure and no message loss, then it will be easy to see that all the sites will be committing only, and all the participants, including the coordinator, is going to commit. But in case of lost message sent from either the cohort or the coordinator, then the coordinator simply resends the message after the timeout. But there are other possibilities due to which either the coordinator is going to fail, or one of the cohorts is going to fail, or the message which is being transaction, it is going to lose. So what happens if the site is going to be failure? So for site failure, we have these different cases. The first case is, suppose the coordinator is going to crash before having written the commit record. Before sending the commit message as the initial message, if it is going to crash, coordinator is going to crash. So on the recovery, whenever it recovers, when the coordinator recovers, it again broadcasts an abort message to all the cohorts, because it has been crashed before it is going to write the commit. So all the cohorts who had agreed to commit will simply undo the transaction using undo log and it is going to abort. Other cohorts will simply abort the transaction, and note that all the cohorts are blocked until they receive an abort message from the coordinator. Meaning thereby, if the coordinator is going to crash every time, the cohorts will be dependent on the coordinator, that what kind of message they have coordinator has sent. And if it has not sent a commit or the abort message, and whenever the coordinator is going to recover, it will be sending the abort message to the cohort. So cohort are going to be blocked till it is able to receive the commit message or the abort message from the coordinator. So this is the first case when the coordinator is being crashed before the commit record. Suppose the coordinator is going to crash after the commit record. Once it has sent a commit message to all the cohorts, and then after writing this commit record into its log, it is going to, because once it sends the commit record, but before writing the complete record, if the coordinator is going to fail, so what happens on the recovery of the coordinator? Since it has committed the record, so log has already stored commit. So whenever it recovers from the failure, so coordinator is going to broadcast again the commit message to all the cohorts. Why? Because the commit record is stored in the log. So whenever it is recovered, it will try to find out its state whenever it has failure. And it finds that the state of the coordinator is to commit. So again, it broadcasts the commit message to all the cohorts and wait for the acknowledgement. So in this case also, the cohorts are blocked until they receive a commit message from the coordinator. Now suppose the coordinator is going to crash after writing the complete record. Meaning thereby, once how this two-phase protocol used to work. First of all, it sends the commit request and waits for the reply in the form of an agreed message. Once it receives agreed message, it sends a commit message or the abort message depending upon the situation, and waits for the acknowledgement. So once it receives the acknowledgement, it is going to complete the record. So, but suppose the coordinator is going to crash after writing the complete record. So nothing will happen because everything has been done. The coordinator and the cohorts has been agreed to either to commit or to abort. So on recovery, there is nothing to be done for the transaction because the transaction is either committed or it is aborted before it is after it is writing the complete the record. Now, the fourth situation is if the cohort is going to crash in the phase one. What happens in the phase one? If the cohort is going to fail, then what happens? If the cohort is going to fail in the phase one, the coordinator can abort the transaction because it will not be able to it will not be receiving any kind of reply from the crashed cohort. So after timeout, it will be resending, but after the resending, it is not receiving any kind of reply message. So simply the coordinator is going to abort the transaction. Suppose a cohort is crashed in phase two. What happened? Then suppose the cohort is crashed in phase two, that is after writing its undo or redo log. So after the recovery, the cohort will check with the coordinator that whether it has to abort or it has to commit the transaction, meaning thereby again there is a dependency of the cohort on the coordinator that whether to abort the transaction or to commit the transaction. Now, committing may require a redo operation because the cohort may have failed before updating its database. If it has already updated its database, then it is not necessary to ask. But even though it has to go to the coordinator and ask about whether it wants if the transaction has to be committed or it has to be aborted. Now, this two-phase commit protocol can be illustrated with the help of a finite state diagram or the finite state automata. Now, this is illustrating the two-phase commit protocol. This is the coordinator side. This is the cohort side. So whenever this coordinator starts its transaction, it's starting the messages, it will be in the state of Q1, and it is going to change. Now, in this finite state diagram, you will be changing the different coordinator will be changing its state or the cohort will be changing its state whenever either it is sending any message or it is receiving any kind of message. So whenever coordinator is sending a commit request message to all the cohorts, it will be changing its state from Q1 to W1. Now, one or more cohorts has replied abort once it will be in the state of W1. If one or more cohorts has replied abort, so it will change again its state to abort state, that is A1, and it will abort all the cohorts. Now, if all the cohorts are agreed, then again it will be sending a commit message to all the cohorts and it is going into the final state. So this is the intermediate state, this is the starting state, and these are the final state, and this is the intermediate state. Now, what happens in the case of cohort side? The finite state diagram of this cohort site is also drawn. So, initially, it is in the state of Qi, and if it has received the message and it has sent an agreed message to the coordinator, then it will change its state from Qi to Wi. Commit request message has been received, but abort message has been sent to the coordinator because this is not able to perform. So it will be sending the abort message. So whenever again it is changing its state from Qi to Ai, and this is the final state. Now, once agreed message sent to the coordinator and coordinator has sent. Now, abort message received from the coordinator. It may be possible that the one or more cohorts has replied abort message to the coordinator. So coordinator has sent all the cohorts to abort. So again, it will change its state from this to abort state. And if coordinator has sent the commit message, which has been received by the cohorts, so commit message will be received from the coordinator. So it will go into the committing state. So abort state and the committing state are the final state, and Q1 and Qi are the initial state, and W1 and Wi are the intermediate states of. So whatever has been discussed in the two-phase protocol can be illustrated with the help of this finite state diagram. But the important issues which are related with the two-phase commit protocol is that it is also called as a blocking protocol, because until unless the coordinator is not going to survive, the All the cohorts are not going to take any kind of decision whether to commit or the abort. And every time they have to ask, they have to agree upon the coordinator. They have to be dependent on the coordinator, and until unless the coordinator is saying commit or the abort, it is not able to do. So that is why this kind of two-phase protocol is also called the blocking protocol. That is all about the two-phase protocol.